So here we are with part 2, starting right off where we left off with part 1. We have this equation here. You've done problems like this before. We did some yesterday. You did some in your practice because I know you did all of your practice because you're a good student. So I want you to try this one on your own. Pause the video, unpause when you're ready to check your work. Okay, so here we should end up with x equals plus or minus 2 root 2 and x equals plus or minus root 7. How do we get that? Well, this again is of quadratic form, so you could have done a substitution. So for example, you could say x squared equals y, therefore x to the 4th is y squared, and rewrite this as y squared minus 15y plus 56 equals 0. Factor that into y minus 8 and y minus 7, and then substitute back in the x squared. Or if you recognize that, instead of writing out the substitution, you can just go ahead and factor it. X squared minus 8 and x squared minus 7 equals 0. Set each factor equal to 0 and solve. Don't forget the plus or minus. We do not have to check for extraneous solutions here, so these should all be good. Next one. Solve this. We haven't done one exactly like this, but we've done one very similar, so you should be able to do this. I want you to try this on your own. Pause the video, unpause when you're ready to check your work. Alright, so here we should get x equals negative 122. How do we get that? Well, this is just like those square root problems that we've done, so it's a cube root though. Instead of isolating the square root, you isolate the cube root. Doesn't matter the root, isolate it. So I isolate the cube root, subtract 7, I get the cube root of x minus 3 equals negative 5. Cube both sides, so x minus 3 equals negative 125. Add 3, x equals negative 122. Because I cubed both sides, I do not need to check for extraneous solutions. Next one. Here, we're going to have to follow the same sort of idea as what we did on the last problem. However, you're going to have to do the process twice. So we can start this one together. I want to isolate one of the root terms. It doesn't matter which one, but I want to isolate one of them. I'm going to do the x plus 4. So we're going to do the square root of x plus 4 equals negative 3 minus root x. Now, square both sides. This becomes x plus 4. Here I have to multiply this out. So this will become 9 plus 6 root x plus x. Now we're going to isolate the square root again. This one, you'll notice, is kind of nice because what's going to happen as I isolate the square root, I'm going to subtract x from both sides and that goes away. So I end up with negative 5 equals 6 root x. Square both sides again. And I end up with 25 equals 36x. So therefore, x equals 25 over 36. Now I do have to check for extraneous solution. So if I go back to the original equation and I plug in 25 over 36 in for x, does it equal negative 3? In this case, it does not. Use your calculator to help you out with that. So if I go to my calculator, I can actually type in square root of 25 over 36 plus 4, and then plus the square root of 25 over 36. If I hit enter, I see that's positive 3, which is not negative 3. Therefore, this is extraneous. So my answer is no solution, because we only had one potential solution, and that one potential solution was extraneous. Last one. I want you to solve 27x cubed minus 64 equals 0. You will need to use the difference of cubes. Pause the video, do this on your own, unpause when you're ready to check your work. Alright, so we should end up with negative 2 plus or minus 2I root 3 all over 3 and 4/3. How do we get that? Factor using the difference of cubes. So the cube root of 27 is 3, the cube root of x cubed is x. The cube root of 64 is 4, so I get 3x minus 4. Set that equal to 0, and that's how I get 4/3. 3x squared is 9x squared. 3x times 4 is 12x. 4 squared is 16. Set this equal to 0. That does not factor. I used the quadratic formula. So opposite of b plus or minus b squared minus 4 times 9 times 16 over 2 times 9. Use my calculator to help me out with these numbers. Simplify as much as possible. 432 is 144 times 3. 144 is a perfect square of 12. Square root of negative 1 is I. So that's how I get 12I root 3. Now 12, negative 12, and 18 all have a factor of 6. So I divided by that, and that's how I got negative 2 plus or minus 2I root 3 all over 3. That is the end of part 2. Any questions? No? Okay. Good talk.